All right, welcome back. We're going to find Riemann sums today of unequal intervals or with unequal intervals. What does that mean? Well, up to this point, recall that we've given you a function and we've cut it, say, from A to B, and we've always made our intervals to be the same. So it was always the same distance between each of our intervals. So our delta x was always b minus a divided by the number of intervals that we wanted. In unequal intervals, it's not always going to be the case that we're going to divide by n so they're all equidistant from each other. And we normally see this when we're given a problem with a set of values in a chart. And this is like the way they like to show on the AP exam as well. So let's go ahead and look at this example, and we'll kind of talk about what it's going to look like and some things that I do as I work these problems as well. So the problem is that the number of miles biked in an hour is modeled by the differential function n for values between 0 and 20, and values of n of t at various times t are shown below. So we know during the hour 0 we've completed 0 hours. In hour 5 we've completed 8 miles. In hour 7 we completed 10 miles. In hour 10 we complete 6 miles. In hour 17 we complete 15. And in hour 20 we complete 10. We do not know, like any other chart, we don't know what's happening between 0 and 5 or 5 and 7. This at hour 6 they may go 0 miles, but in hour 8 here they may go 100 miles. So we don't necessarily know what's happening with the information that's not given. All we can do is go off of what's given. So the first thing they're going to ask us to do here, or I'm asking you, is to use a right Riemann sum to estimate the number of miles traveled in the first 7 hours. So whenever I'm given a chart, and this goes with pretty much anything, I like to go ahead and chart it out so I can kind of see what's happening. So I get the point 0, 0, and you might even label it as 0, 0. And then here at 5, I'm coming up here to 8, and it's not necessarily that it's important that they are equidistant and you have nice clean numbers. If you want to get fancy with it, you can. But as you're taking your test, you're going to notice, hey, I don't have a lot of time, so I can't spend a lot of time working with making it nice and exact. So you get the same point where I get 0, 0, 5, 8, 7, 10 if I just go ahead and label those points. And then here at hour 10, I go 6, so it's going to be a little lower. And again, you can kind of estimate maybe where they're going to be here. In mile 17, notice my distance are about the same across there, but they're obviously not the same. Hour 17, I'm up here at 15. So maybe up here at 15, and then out here at 20, I'm back down at 10. So again, not really important that that these are equidistant or that they look like they're supposed to. I've labeled them, so that's what they are. So it asks us to use a right Riemann sum to estimate the total number of hours traveled in the first 7 hours. So for the first 7 hours, I'm looking at just this information here. So up to hour 7. If I want to do a right Riemann sum tells me to use the rightmost point of my interval. So here I'm looking at 5 being my rightmost point that I know something about between 0 and 5. My other rightmost point would be 7. So I would break this into 2 regions. And I would do a right sum, or R of n, for our right Riemann sum as being, and again, this is our notation that we're going to be looking for, is going to be f of 5 delta x sub 1. We're going to now label this delta x sub 1 because this change in x is going to be different each time we run through. The next one is going to be f of 7 times delta x 2. Again, notice I'm just going to increase my delta x subscripts until I run out of delta x's. Now I can go ahead and find for the first 7 hours. So now I'm going to find my f of 5. F of 5 is 8, because that's given to me as my point, and delta x1 is 5. To that we're going to add f of 7. F of 7 is 10. And to that we're going to multiply our delta x2. Delta x2 in this case is going to be 2 units. So we get 40 plus 20, or 60 miles. So we would have traveled 60 miles in the first 7 hours, theoretically. Again, we don't know what happened in hours 1, 2, 3, 4, or in hour 6. We can only assume there's going to be somewhat of this so that we can estimate those miles. In part B, we're going to do a left Riemann sum to estimate the number of miles traveled in the first 17 hours. So now I'm here on the left side of each of my endpoints, and we're going to go for the first 17. So we're getting rid of this stuff here. So we'll do a left sum. And now I'm going to find f of 0 times delta x1. I guess I should get that there just a little more. I guess we don't need to see the chart anymore. To that we're going to add f of 5, that's my next left point that I know something about, times delta x2, plus f of 7, delta x3, plus f of 10. And that's going to be times delta x sub 4. And that's going to be where we're going to end, because once we get to 17, we'll have the first 17 hours covered. So f of 0 was 0 times delta x, which is 5. To that, we're going to add f of 5, which is 8, times 2, which is our delta x. Again, delta x is that change in the x. F of 7 is 10, and then our units, or delta x is going to be 3 in this case. And then f of 10 is 6 times 7, which is going to be the distance between 17 and 10. We can go ahead and add those together, or multiply and then add, so we get 0, 16 plus 30 plus 42. So here I got 72, 82, 88 miles will have been traveled. Yep, there you go, 88 miles traveled. All right, and we can do this with all of our different methods that we've talked about. We've talked about the midpoint. So the next one I want to use is the midpoint traveled in the first 10 hours. So what do we do with midpoint? Midpoint's a little more confusing and a little tougher, I think, to be able to come up with. So midpoint, if we think between 0 and 10, we don't know the midpoint between 0 and 7, or sorry, we'll go 0 to 5 here first. If I think between 0 and 5, the halfway point or the midpoint would be 2.5. We don't know how many miles we traveled in 2.5 hours. But we do know at hour 5, we traveled 8 hours, or 8 miles. In hour 7, we did 10, but again, 7's not the midpoint of any of these values. The only midpoint that we know is between 0 and 10. The midpoint between 0 and 10 is 5. So I'm just going to create one rectangle for this, because that's all I know is one rectangle. So for my midpoint, I'm going to have f of 5 times my delta x, which f of 5 is going to be 8, and my delta x is going to be the entire distance, in this case, is going to be 10. So that's going to give me 80 miles traveled. Oh, I guess you couldn't see that, could you? So we took f of 5 times delta x, which was 8 times 10, which gave us 80 miles. Okay. So midpoint, a little more confusing and a little more irritating, I think, for most people, because you have to figure out what midpoints we know. So if we had a 2.5 here, we would use that, and then if we maybe had a 7.5, we could use between 5 and 10. But since we don't, the only midpoint that we know something about would be the 5 here. All right. And then last one, we're going to use the trapezoidal method for the first 20 hours. So for the first 20 hours, our trapezoid, remember trapezoid formula, our bases are going to be the heights of the values at 0 and 5 for the first one. So we take 1/2, and again remember that 1/2 is going to be constant throughout all of it. So I can take 1/2 times all of them in order to eliminate having to write 1/2 times each one of my intervals. So we have f of 0 plus f of 5. That's going to be in parentheses times delta x1, which is going to be that distance in there. To that we're going to add, I'm going to run out of a lot of room here, ain't I? So we're going to have f of 5 plus f of 7, and again times delta x2. To that we're going to add f of 7 plus f of 10, and then we're going to multiply that by delta x sub 3. And then we're going to add f of 10 plus f of 17, and then delta x sub 4. And lastly, we're going to have f of 17 plus f of 20 times delta x sub 5. And again, if you want, you could put 1/2 in front of each one of these. I like to factor it out so I don't have to write 1/2 each time. Because ultimately, we can take all of these values added together, divided by 2, and it's going to give us our area as we discussed when we first talked about the trapezoidal method. So here we have we have 1/2 of f of 0, which is 0, plus f of 5, which is 8. So we have 0 plus 8. If you want to put that up on our top, we can. So we have 8 times delta x1. Delta x1 is going to be 5 units this time. To that, we're going to add f of 5, which is 8, and f of 7, which is 10. So we have, if we have 8 and 10, that gives us 18 times delta x2. In this case, delta x2 is going to be 2. To that, we're going to add f of 7, which is 10, and f of 10, which is 6. So we get 16 times delta x3, which is going to be 3. Again, you may, if you want, if you need to, put in delta x1, delta x2. That might help you a little bit to see maybe where you're going. I guess I probably should have done that before. Oh, that was a 5, I guess. That might help you maybe see where your delta x's are going to be down in here. Where was I? So we got 1, 2, 3, so delta x4. So f of 10, which is 6, plus 15, so we get 21, times delta x4, which is 7. And then finally, we're going to add f of 17 and f of 20, so we get 25, and that delta x is going to be 3 units. And then we're going to end our brackets. We're getting there, aren't we? So we have 1/2 of, we have 40 plus 36 plus 48 plus 147 plus 75. And I'm going to be lazy. I'm going to pull out the calculator just because I can. We have 40 plus 36 plus 48 and 147 and 75. So we get 346 in there divided by 2, and we get approximately 173 miles traveled. And that gives you kind of an idea of where we're going to see some unequal parts and how they could possibly test us on the exam. If you have questions, let me know. Good luck. Before we leave, just very quickly make sure you write the formula out as you do it. This sentence up here is worth just as many points as this answer is here. And a lot of the times they won't give you any points for this answer here without this sentence up here. Alright, so make sure you have that, especially that delta x and those function notations. So good luck, enjoy. If you have questions, let me know.